It's my great pleasure to welcome you all to another webinar as part of the CSPC 2023 pre-conference sessions. I'm joining you today from the University of Manitoba. The University of Manitoba campuses are located on the original lands of the Anishinaabe, Cree, Ojibwe Creek, Dakota, Dene peoples, and on the homelands of the Métis Nation. We honor and respect the indigenous peoples in these lands and their traditional ways of knowing and caring for this land, as well as the treaties that were made on these territories. We acknowledge the harms and mistakes of the past, and we dedicate ourselves to move forward in partnership with Indigenous communities in a spirit of reconciliation and collaboration. My name is Hansi Ahmeden, and I'm the Associate Vice President at Partnerships, Knowledge Mobilization and Innovation at the University of Manitoba. And I will be moderating today's pre-conference session on the impact that science and innovation have for our society. I'm very excited for the discussion today, as besides being part of the University of Manitoba's science innovation ecosystem, I'm also the president of the Canadian Society for Molecular Biosciences, which represents the whole breadth of the Canadian molecular bioscience research, and I strongly believes in the role that our training and research has for the society across all sectors. With this in mind, I'm extremely grateful for the opportunity to have had the opportunity to assemble this panel of outstanding scholars, and let me start with introducing them to you. I would like to start with Dr. Dorte Dahl, a professor and Canadian Excellence Research Chair at the Centre for Earth and Observation Science here at the University of Manitoba. Her achievements have been in leading ice core drilling and subsequent analysis of the ice core data in conjunction with models to determine past climate and how it affects the Greenland ice sheet. Welcome to the panel. Thank you for joining us.
Thank you very much.
Thank you. Next is Dr. Tariq Moroy. Dr. Moroy is a full research professor at the Montreal Clinical Research Institute, the RCM, and director of the Hematopoiesis and Cancer Research Unit. He is a full research professor at the University of Montreal and adjunct professor at McGill University. He is a member of the board of directors of Research Canada since 2016 and its chair as of June of 2023. Dr. Moroy, welcome and thank you for joining us today.
Thank you very much for the invitation.
Last but not least, I would like to introduce Sarah Framboise. Sarah is a PhD student studying biochemistry at the University of Ottawa, and her research investigates the use of yeast as a model organism to answer important questions about human disease, cancer, and cancer. Sarah completed her BSc in biology at York University and was named one of York University's top 30 alumni under 30. Congratulations, Sarah. Sarah has been heavily active in the fields of science policy and science communication. She founded the Ottawa Science Policy Network, a student-run club that at the University of Ottawa, which recently published a peer-reviewed study on graduate student finances in Canada. And we're looking forward to hearing you talk about it. So welcome to the panel and thank you for joining us today, Sarah.
Thank you so much. I'm excited to be here.
So with that, we actually can move on into the panel discussion, I would say, right? And being less formal as I was like right now. So the panel discussion, I would like to start and pose a couple of questions to each of you, and maybe you're going to go in turns. And I would like to start with Dr. Dahl to frame a little bit the setting which we're going to have the discussion, if that's okay. Dr. Dahl, can you explain what the importance, or can us fill us in what the importance of the North Open Water in the Baffin Bay is?
Well, far up in the North Baffin Bay, there's an area that's called the North Water Polymer. It's a big water area that's open more or less the whole year round. It's in Greenland, it's called Pikialasorsuaq, and in the Inuit, it's called Savayuaq. And it has enormous importance for the people living around the Baffin Bay because it is an open area, so it's very rich on marine resources all the year round. And right now, we see that due to climate change, we fear that the conditions are changing and maybe that it will not continue to be an open water area. So I think it has great importance to understand the climate and what's going on so we can see how the living conditions change for the people living up in the north, both in Canada, but also in Greenland.
And so thank you. And so that actually takes away my second question that I wanted to ask is like, how does the change in ice condition impact the society of the communities that are surrounding this area? So, and how does researching into the changes can be used to guide the response of those communities around us?
Well, I go up on the middle of the ice sheet, especially the Greenland ice sheet, and we drill ice cores and see how the climate is changing back in time. But we also follow the melt from the Greenland ice sheet, and we can see that with the strong warming we have in the Arctic, we get more and more melts in the Arctic. So the Greenland ice sheet and also the Canadian ice caps are losing more and more ice, and this gives a lot of fresh water into the Baffin Bay area. And this strongly influences the currents and the conditions there. So in that way, it impacts all the societies living around the Baffin Bay. So in many ways, I just wander up on the ice. There's not a lot of people living there, but the research we do and the results we find really impact all the societies, all the community area, but actually also all global people, because changing sea level influences all of us.
So, and I recently spoke with you on a different occasion, and we learned that you were successfully drawing through the glacier into the bedrock, and noticed that you learned something from the composition of what was under the ice sheet. Is that not so? You were surprised by the finding. Can you quickly comment on that and how that impacts maybe the sweet, like the freshwater contribution to the ocean, and what the impacts of that are?
Of course I can. I think most people are not aware that when we talk about mass loss from both ice caps and glaciers, then half the mass loss is from melt around the margin of the ice sheets and caps, but the other half is kind of very fast flowing ice that streams out towards the margin. And this is actually half the mass loss that comes this way. And we don't understand very well why it's sliding and what happens when the climate warms and the ocean warms. Mostly we see that we get more and more ice coming out through the ice streams, and thereby it accelerates the loss of mass from the Greenland ice sheet. But in reality, we don't understand it very well. So by drilling these deep ice cores, and the one we're drilling now through an ice stream, we try to understand what's happening, so we can make better predictions of what's going to happen with the loss of mass and the increase of meltwater coming out in the ocean from ice caps and ice sheets. So what we found was the whole ice stream, which is 2,670 meters thick, where we're drilling is flowing totally like a block, just streaming out towards the ocean. And in that way, it's actually contributing more to sea level rise than we had originally thought. So that was quite an interesting result.
So that was surprising. So if this, as you mentioned earlier, this not only impacts the local communities but also the global community, and because it changes like the seawater levels. But do you have But I mean, the first people to see this are the local communities, right? Do you have any examples how your research data or the work on the ice shield is taken into the community? Is there community-based research examples? Like how does the information flow from what you're finding to the researchers, or like to the communities, actually, I should say?
Well, actually, where the ice is melting, and especially where the ice streams are coming up, it's very nutrient-rich water that's coming out. So this is where the fishery is happening, and this, of course, has enormous interest for the communities, how the conditions is changing and why the fishing conditions are changing. And we have quite a lot of contact with communities, both in Greenland and also in Canada, about these conditions, where for us, their knowledge on how the fishing is changing and what they observe is really, really important for us in understanding, how it impacts communities. So a strong collaboration there is needed.
So you're learning from the communities how the changes impact. Is there any, how do you feedback your findings into the communities? Are examples of where, or can you suggest a mode of engagement, how information that you're generating might actually help local societal decisions or political policies, for instance?
Well, if we can see that some of the ice glaciers and ice streams I would say especially in Canada, where its smaller ice caps is being depleted and might disappear in the next years, then we can see that this will heavily impact the area for kind of living resources in that area. And this is something we need to communicate, and we do communicate to the communities. So in that way, going to the communities and having consultations and presenting our findings and how we see the importance of melting water and how they observe the melting water, I think is the right way to communicate.
So what you're saying is reaching out into the communities and disseminating the information in the impacted area is a key thing to actually make it
that's right.
Meaningful,
and also
right?
Involving their knowledge. Absolutely.
Yeah. So it's a okay. Is there anything else that you want to mention? Otherwise, I would move on and ask Dr. Morroy a couple of questions.
If I could come back to the Pikiala-Sosuwak or the North Water Polymer, then we believe one of the ways that it's maintained is because we have some ice bridges forming in the straits to the north, especially the Nares Strait. And when the icebergs pile up and block the passage, that's what keeps the water open in the winter. But with the warming and the smaller amount of icebergs coming through, there's more and more years where these icebergs don't pile up, and then we see the steady stream of ice coming down. And this is what blocks or kind of closes the open water, and is what we fear will become more and more common in the future.
So what would be the impact? Like, how does the societies react to this? Because I mean, we agree that probably there's nothing you can do about that, right? But you right? I mean, you cannot do anything to prevent the melting of those bridges, right?
No, but their knowledge on the edge of the Polymer and how far the sea ice has reached during the years, is a way of documenting what's happening and how the conditions are changing for the communities.
Okay. So thank you very much. So let's move a little bit on to a different aspect where I think, actually, I forgot the question I wanted to ask. What was the technology? Sorry, forgot about this. What were the key technologies that were required for you to access actually the drilling technique? Is there any major technology breakthrough that you had that was implemented that would now enable you to do this drilling exercise or the drilling experiment?
Well, it's very specialized technique. The ice core drills we used are developed mainly by the researchers in Denmark to do this drilling. But one thing that has changed in the years that I've been involved in this is that we put a lot of emphasis now in leaving a clean site, not leaving anything behind, not polluting. So we build buildings that we can pull to the surface on skis. And when we make trenches under the snow to do our research, we make them with big balloons. So that it's kind of a snow cave we're working in. So when we leave it, we're not leaving any material behind. And that's something we put great pride in, and is a kind of technology development in our field.
So thank you very much. It's about reducing the ecological or the imprint on the environment, the footprint on the environment.
Absolutely, yeah.
Excellent. So that gives me a transition to Dr. Morroy, which I actually almost forgot, was to ask the question about can you talk about how innovation and technology development has impacted health research from your impact angle to it? Maybe also touch a little bit on what that means for patients.
Yeah, certainly. I mean, there are numerous examples how the new health research innovations have impacted society. Think about the vaccines. We just have lived through COVID pandemic and we have witnessed the development of messenger RNA vaccines, which have, accepted for most part of the society, but certainly some parts of society were very skeptical towards these new vaccines, but there are a technical and innovation breakthrough. I mean, these vaccines can be made quickly, they can be adapted quickly to new strains. For a biochemist, this is just wondrous, if you want. For the layperson, it may also have an element of unknown and therefore fear, because all these new technologies, if society accepts them, you need a base of trust to science and medicine and the medical complex, the industrial complex. And in some parts, you can see that this trust has a bit at least eroded for many reasons. So the impact of the new health technology and the acceptance, this is major changes in society. I mean, there are many, many examples. Think about imaging technology. You have huge capacities for imaging. You image something, you discover something that you didn't look for. What do you do with this? What does it mean? Do you follow up on this or not? Is this? Then you have diabetes patients that now have implanted pumps and don't have to bleed themselves every day. They can live different lives, better lives. So there are a lot of positive examples. You have genetic testing for diseases that develop later in life, but you know the result before. You have prenatal testing. The genetics, you can test the unborn genetics and you can predict there will be a disease or not. That is maybe a technological breakthrough, and you understand much more of the disease, but you leave the parents to be with dilemmas about their unborn child. I mean, we understand better genetics, we have a test, we understand the disease, a monogenetic disease, then we go to the patient and the patient is thrown into ethical dilemmas and into worries and to fears that have been taken care of by doctors. Again, you have to inform them correctly and guide them through. So it's complicated. It's complicated. But on the positive side, we increase life expectancy. We increase what is called the quality of life years, or the life that's still spent. Is the quality better? Yes. There is much more possibilities to take care of patients. Many more technological breakthroughs. Now, a leukemia patient gets a sequencing of a panel of 50 genes, which hasn't been done before. The information sometimes is complex. Does the patient really understand what has happened? So there is more complication, there is more possibilities, but there is more fear, right? And more social impact. And the other thing is the economic impact. So all these things cost a lot of money. That means the healthcare system will be more expensive. Are we asking the patients to pay more? Or are the system, the payers, chip in more? It is. So we have a lot of good things coming through healthcare innovations, but we have consequences.
Okay, thank you, Dr. Moray. I actually would like to follow up on two things that you mentioned in your response, and maybe reach back to Dr. Dahl about this in terms of, like, you mentioned that for new developments or changes in how things are done, it requires trust into the medical system, right? Or into the researchers that do this. Dr. Dahl, how do you feel, or maybe I'll ask that later when your power cord is good. How important is the trust relationship? Like, is that something that you would also agree is critical in your research and in explaining? Well, I guess I asked that in the second question. The trust relationship.
Well, I think a trust relationship means everything. I mean, when you communicate, if it's a kind of healthcare or if it's knowledge about the Arctic, you just don't get anywhere if you don't have the trust of the communities. And I think that's actually a very important issue, because, I mean, it's not really the way to do it for northern research or kind of southern researchers like me, just to wander into communities and say, I know everything and this is how it should be. Because you need to build that trust. They need to know that you also respect them, and their knowledge is important too, before you really can move. So I think trust is everything in every relations, actually.
Okay, and so how do you build this trust relationship? What are a couple of key? I'm not asking about how you go into the community, but what are a couple of key parameters that one has to have for this trust relationship to be developed? Because Dr. Moray just mentioned that, you know, some people might be afraid of what the technology brings, right? And being afraid is an emotional state that is not necessarily very, very good in order to build a trust relationship, and it's built on how do you overcome these kind of things? What are the prerequisites for it? I mean, well, sorry, go ahead.
Well, I think you have to be a human being, and I mean, you have to come to the communities as a person and start very slow and build some personal relationships and listen to, how is the life in this community, and how's the families working, how's the school doing, how's the health of people in the society, and build trust. Tell about your research and introduce it, and come into a dialogue about why it's important, and how being community-based research together with the research can kind of work towards the same goals. So I think the arrogance of coming and just think you can solve everything is what we need to avoid, and just simply respect the people we're working with. But it also brings me. I don't know if that's appropriate if I ask Tarek, because I think health in the north is something that is of great importance as well, and difficult.
If I understood the last sentence correctly, how to build trust, is that what you, yeah. So I think education is some easy point. I mean, if you do not work in biology or medicine and you work in, let's say you are a lawyer or you work in construction, and then you are in the middle of your life and somebody tells you about messenger RNA vaccines, you see, what is this? And what do they want to do to me? And this is one thing. The other thing is information. I think we lost control with social media on information, at least a little bit, because a lot of information can be put out there, which is uncontrollable and which, it's difficult to follow up. So these are the two key things: education in high school, and I think this is really important. And communication and information, how can we control it without stifling, free expression? I don't know, but it's a critical element.
I think that's so true. And I would also say, when you come up to the communities, I think maybe in information and education are the things that are in demand.
But when you go on Twitter or on other social media, there's a lot of good information, but there's a lot of things that can be misleading, and then other people try to manipulate via Twitter. It's very difficult to contain, because as I said, everybody has the right to express themselves. You want to assure that this is a freedom. But then, if theories take ground that are counterproductive to public health, how do you deal with that? I mean, that's difficult, and I think government has a role here, and it's a very difficult one. How do you decide, and you tell somebody you have to be vaccinated, and they say, I don't want to be vaccinated. Explain the principles of public health without telling someone what to do, and then put a restriction on their personal freedom. I think it's a real problem, and I hope there will be people in the future educated enough to manage that. That will be critical. We don't want to have people that live in fear and do things that later everyone would regret. I mean, this should be avoided.
So just to capture this a little bit, is like, even so communicating it alone is not good enough. You have to be able to communicate in ways, or being heard in ways that actually make sense, to avoid these kind of fears, and to train people to assess information, right? And so I think that's what you're trying to say with that. So, and that and I think that leaders in communities, whatever structure these communities have a key role in facilitating that, right? So education there is important as well. With this in mind, I would like to ask a question about innovation again, a little bit in that sector, Dr. Moroy, with respect to you described all those fantastic innovations that occurred, and like they solved, like, also, I mean, the tremendous ability of responding to the pandemic is an example for that, right? However, or the ability of the technologies that Dr. Dahl describes, they are also developed. They did not show up today, right? But let's go back to the medical case. A lot of people see CSI, and brings me back to the communication piece. So if you do look at television series where CSI have an identified virus, and 14 days later you actually have everybody cured, and it's completely reversible. That's probably not how the reality works, right? Can you maybe elaborate a little bit about the timelines that led to, for instance, development of the vaccine, or like the insulin pump? Is that like, when did this start? Did this start a year ago, or when? And what needed to happen for this to actually come together so fast?
Well, thank you. Actually, many scientists, me included, take this as an example to show how critical basic science is. And also, Sarah will agree, the funding of graduate students in the effort of basic science. So, people 20 years ago or even longer, people thought about, how make liposomes to transport drugs into the bloodstream or make it deliver into cells, and thinking about, on a biochemical basic level. And other people wanted to stabilize RNA, changing nucleotides, and then, they came together and then made, okay, we can make a particle, a nanoparticle, we put RNA in there, and we could make a cancer vaccine. They weren't thinking about the virus, right? And then the virus comes, and then these people that have developed over many years this technology, the knowledge about virus, knowledge about how messenger RNA molecules work, how the structure is, how you modified it, and that's not degraded. And then they come together and say, we could use all this knowledge that was created in basic academic labs over decades. And, we could, the BioNTech founders have sat on their kitchen table, at least is what they say, and said, let's give up cancer for a while, and let's use the technology that making making a vaccine against COVID, using the messenger RNA modified and our micro particles. So the basic science lays the foundation without knowing, right, what it's good for 10 years from now. So this is the other thing that government has to understand. And some governments do, and some governments feel that they would like to put emphasis on the innovation side and not on the basic research. But without 20 years, people looking, after how messenger RNA works, you wouldn't have had the vaccine. So therefore, I can use this platform to say how important it is to fund basic science. And basic science is done by PhD students and postdocs most of the time, right? A big part of it. And they're funded by grants, and the grants have to be able to pay their salaries. And Sarah has made the point that if this is not done right, people will go elsewhere. They won't go into labs. And I think the paper that Sarah made, I make a little bit of wrote about this. I think this publication that you did, Sarah, had more citations than many other papers, right? In a very short time. So I think if you may, Hans, this could be a nice transition to. Don't you think?
That's a fantastic transition into asking Sarah about what the role of graduate students is, for instance, in this innovation or discovery research ecosystem. But I would also like to ask you to talk a little bit about how important the graduate students are, or that graduate student training, or general undergraduate training in universities, to help, for instance, with the problem that we just identified of being able to understand change, right? And how that goes. Maybe you can speak to that a little bit.
Yeah, and I've been furiously jotting down points as the conversation's been going, so I think this is a great discussion. And I think I've been involved with a lot of advocacy over the last few years on graduate student and postdoc funding in Canada, so I've had to kind of get better at defending the role of the graduate student and postdoc a little bit more. And if we think of science and research as an ecosystem and a larger scaled item here, we can imagine kind of like a pyramid type thing where graduate students and postdocs are really the foundational piece at the bottom of the pyramid that hold the rest together. Basic research would also be at the bottom of the foundation that allows for mission-driven research and things like this to occur at the top scale of this. So it is a large ecosystem that sits on this foundation. And as Dr. Moray mentioned, the graduate students and postdocs are often the ones in the labs with their hands dirty, doing a lot of the research. So if we're thinking about what their role is in innovation, I would say that they're the frontline workers. They're the ones who are at the very base of all of it. So in terms of their role to play, I think as the next generation coming through the system, they also come with new skills and diversity that continues to kind of flush through the system. So the more diverse that graduate student and postdoc talent pipeline is, the more that we will benefit from this in 10 to 15 years as they continue through the ecosystem as well. So I would say that their role is paramount to the future of Canadian innovation and the current withstanding. So that's kind of more of a broad scope, but I can refine it a little bit to going forward.
Okay, so thank you, Sarah. So you mentioned that an aspect of graduate training, and you kind of touched on that I'm often that I like to emphasize as well, is that, and that ties back into the funding scheme and like how we as a society adjust to change. We talk about knowledge mobilization and impact, right? It is, I mean, there is the one way of formulating or writing papers and disseminating the research in a scientific context, but all of the members of that ecosystem that are involved in it, like undergraduates, graduate students that partake in the research endeavor, they are also ambassadors for that research, and they are part of the knowledge mobilization aspect in there. So I think that there is a value chain idea here that everyone can see through the graduate student program. And so, for instance, but then there's that group of graduate students that go on and do the research and whatnot. That's probably the top 10, top 20% best funded ones. But I mean, there's that whole set of 80% of all the graduate students that are maybe not ending in a research lab, right? Mm-hmm. What happens to them? And is this a lost opportunity, or how are they funded? How do they get to be part of that innovation system?
Yeah, and I think the demands on graduate students these days are significant, right? We're expecting graduate students to have such diverse experience. You can't just be a wet lab scientist. You have to also be a communicator, and you have to be able to talk to policymakers and your family about science and things like this. So I think this is fantastic. I don't think it's necessarily a burden. I think we're just creating a generation of scientists that have a large subset of diverse skills, which will only add to the community in the end. But it does lead to a system where we are asking our PhD graduates to maybe enter diverse careers at the end and not necessarily go straight into a postdoc or a faculty position. So what I actually like to say in meetings with policymakers is that the guaranteed return on investment in any sort of graduate training is that person, the high quality personnel who is leaving with a PhD. And I think if we look at them leaving academia as a loss, it's a detriment to the system, because I think in reality, this is a highly qualified, highly trained, highly analytical thinking type person who is going to apply themselves to the Canadian economy in diverse ways. So although they might not stay in academia, they are contributing to the private sector, they're contributing to the public sector, they're going to work in government, they're going to work in policy roles or anything like this. They're starting nonprofits, they're working in industry. So they are really applying themselves in other ways. And I mean, I hate to use COVID as another example, but we did see this with COVID as well. When we were in a moment of a pandemic, we had amazing teachers on the ground who were able to work on the ground. We had PhD graduates or people who were able to take this diverse information and deliver it to the community because they had this diverse skill set that was going on. And those people were mobilized throughout the community, not just in academia. And if they weren't all in academia, then we wouldn't have ended up well, right? They were in the Public Health Agency of Canada. They were working for the federal government. They were in all these diverse roles. So I would say that's kind of where I see that going.
Yeah. Thank you, Sarah. So you just described how important you made a very good example how diverse the training set and the skill sets is that researchers that go through or like graduate students that go through the academic training route are, and then what the value add is for the society in general. But that also raises the question: how do you prime this pipeline of researchers, right? How do you convince somebody to go into this, into an academic route, into a research stream, when they know that maybe they're not going to become a prof, or they don't want to be Sheldon for that matter? And how do we do this as a society? How do you making sure that it's primed good enough?
Mm-hmm. Yeah, it's a good question. And I mean, I'm biased in my answer there because I do think that the funding is a huge part of this. I think if we're creating a system that works for the people who are in it, then they will stay. And if they're leaving, it's for a reason. So I would challenge that if we are seeing a situation where we're kind of excluding people from the system, then that's where I see the detriment. And again, if we imagine kind of the decisions that are being made at different interface points along that pipeline, if we're asking undergraduates to pursue graduate education, what factors go into that decision? And often it's at that interface that we see these leaky pipelines where we're having like a filter on it, where we're not allowing certain people to go through because they can't continue on financially through it. So I think that's where I see the biggest detriment in terms of the leakiness of the pipeline. But in general, I would say maybe I'll end it there. I think that was good enough.
Okay, thank you, Sarah. I would like to take this opportunity to cycle then back to Dr. Dahl, because she has a little bit of a background from a different funding environment, or like an like science system than the Canadian system alone, right? So can you maybe reflect on strategies outside of Canada that or observations with regard to the graduate student pipeline and the funding from outside of Canada and how that is recognized?
Yeah, I can. I mean, before I do that, I'd like to say that the thing we can offer that I think also is very important is to include and involve students and bring them up in the front by giving them really, really interesting and relevant research and research questions to work with. And I see that that's a really, really important factor in kind of getting and having engaged students, is that they really feel that they can move things and they learn things. That's I don't know. I was thinking about if I should say it or not. But in Denmark, where I came from before I came to Canada, being a PhD student, you give them a normal salary as if they go out and have a job. So as soon as you reach that level, you're given a kind of a normal wage. And I find that, and I know from the students at University of Manitoba that it is a barrier that the salary for PhD students is pretty low, and that can make it difficult for students to stay in the environment, just as you said, Sarah. Yeah, and so yeah, I think that's probably the most important. And I'm not saying anything you didn't say, Sarah, that you have to give conditions and salary so you can follow your interest and your curiosity and work with research, regardless if you're staying in the system or you're going to be an ambassador in the real life with your knowledge and your way of approaching problems. That is also part of what you learn at the university. Yeah.
Thank you, Dr. Dahl, for that. I think that ties very much with what you were thinking, Sarah, and I think it also goes along the lines of what I often feel is that the career path in itself needs to be predictable, and you cannot predict out that you're going to be in a debt by when you're completing this grant, and then then afterwards, even when you make your career point in research, you do not know where the funding comes from. I think reliability of that career path is critical for making this an attractive career choice for our youth in Canada. And I think we will depend on those, because in a time of hyper innovation, we need more of those hyper innovators and more multiple skilled persons that actually can and are able to communicate these emerging technologies within the society. And that means like to the lay people or to decision makers. And that brings me to the next question. Sarah, is like, how can we promote, besides having the pipeline, how can we promote collaboration between the scientific communities, both policymakers and industry leaders, to best align science with social needs? And I think that also ties on the example that Dr. Dahl was talking about, the impact of her research on the communities in which are located with Sarah. And
yeah, I think it's creating graduate students who also, like I was saying, have diverse talent that can be adapted to the needs of the time. I think there's also an aspect of this that is very industry focused, where any person really in Canada right now who's working in industry has a very distinctive requirement for talent that they're looking for right now that just isn't being made in Canada right now. So I think if we can highlight kind of those niches that require high-level talent, that would also help as well to make it more streamlined. Because I think in those cases, we're asking like Canadian businesses that operate in Canada to recruit international talent to bring them into Canada. But really, we're such a diverse community, so we should be meeting the demands of industry as well. I think in its entirety, to promote more collaboration between these groups, I think it's just visibility and networking and having opportunities for those interactions. Scientists and in general, science has kept itself in quite a big silo of academia, and I think it's easy for us to kind of stay in that silo because it's comfortable. And we're amongst peers and we feel seen. But I think it is important to make those interactions with policymakers and with industry to be able to kind of meet those demands or promote collaboration between those groups. I think there's a lot of want and desire for it. So I think having a system and funding opportunities that promote those collaborations are also super important. I know some of the tri-councils have started a lot of research partnership type programs. And I think these are really great initiatives that help promote that. From like a next gen lens, I think there's also room to have promotion of more interdisciplinary type studying where students can get diverse experiences on the backgrounds of their education as well, which would help with making those connections. But yeah, those are a few ideas that come to mind.
So that brings back the question, so if you are in a very financially tight situation in your career path, would you be able to take on additional non for your research project related kind of training opportunities, like for instance, engaging with policy and something along those lines? I mean, that limits it basically, right?
Absolutely, yeah. There's a lot of situations too where students are like limited to work outside of their studies as well. So that's kind of a detriment as well for asking students to be more diverse and have those experiences. Then we have to like promote them in our policies as well. So yeah, I totally agree.
So with that, talking about limitations, I just want to bring it back to Dr. Moroy and the health research aspect and the delivery of innovation in the health sector. Can you identify a couple of, or what do you think are the limiting factors that will become challenges for the Canadian health research and science innovation ecosystem as its complexity can be described, I guess, with words?
Yeah, thank you. Of course, funding is an issue because we compare ourselves to other countries, for instance, Germany, where you are, Dörte, now. I'm a member of a panel on German excellence strategy, and the amount of money that flows into universities and research for what they call excellence clusters is significant in the hundreds of millions, approaching billions of euros for whole Germany, of course. So these are the competitors: UK, France, Germany, Japan, and the United States. And if we compare Canada for the R&D output per GDP percentage, Canada is unfortunately lagging behind. So the question comes, does Canada want to be competitive on this international level in research and innovation? Then it has to fund the basic research at universities and research centers that's going on all across all disciplines. So this is the typical tri-council funding. This is the first barrier. So we look at our neighbors to the south and the NIH budget, and we get green with envy, right? But of course, then you cannot compare Canada to the US all the time. The second barrier, and that's what we're talking about, I think the barrier is to get PhD students and postdocs with this small funding and make them, get them excited and keep them in the labs if there are other opportunities. And the third barrier is, how to translate innovation. Now, this is not easy at all, right? So you have data in the lab and you have findings, you're excited, you're an academic, you want to translate something, and then, somebody with more knowledge of industry comes along and says, yeah, that doesn't work like that. So there's a big gap for academics like me to understanding what do you need to bring, a discovery into application. So the engineers do a much better job than the health scientists. engineering is different than health biology. It's not that there's money there, there are funds there to help translation, but a lot of discoveries, fail the test of application because it's just not there. The idea is good, but until you get it into innovation, it's very difficult. And the third barrier is economy, is marketing. Once you have a product, and even if you have made a discovery and you have a product, you have to get it to market to be successful. That's another barrier, and it's out of the reach of a scientist. It's just other mechanisms that we don't understand so well because we are not trained for. So you have these funding, you have translation, and then you have, the economy has to accept the discovery. But still, it worked for so many things, right? As I said, imaging, vaccines, diabetes pumps, genetic testing, that all penetrates society. But there's a huge bulk behind of discovery that made this possible, and a lot of discovery that's not yet translated into, everyday application of innovation. So these barriers are there, they're recognized also, and there are programs to overcome them, but it's not an easy thing. I think there's work to be done.
Anybody on this? Something to add? No? Then I have a question.
I have a small thing I could add, and you'll have to correct me if I'm wrong, because I haven't been so many years in Canada yet that I feel I have a total overview of the system. But it seems to me that when I talk to researchers, it's often they say it's really difficult to get funding in Canada. And when I look around, I see that there are many very, very big and very competitive programs, and often very top-down related. But it might be difficult for researchers to get kind of significant grants to approach their own ideas and build around them. So I mean, I see that you could call it that there might not be so many venues to create Einsteins in the system. And I might be wrong, so I'd love you to correct me, but that's kind of a little how I see the field.
Well, I think there is funding, and there are people with smart ideas, and there's certainly a few Einsteins around. I think it's a bit of we draw a comparison and we compete. If you look at a group in another country does work on the same large question, and the funding is tenfold higher, and given the technology we have today, sometimes throwing money at the problem helps and you advance, and then Canada is lagging behind. Not always. Sometimes you have to be smart, and then it's not only the money. But I think the competitive aspect between the countries is really important. We want to have people that come to Canada as postdocs, because there is abundance in possibilities. And in the year 2000, when I came to this country between 2000 and 2006, Michel Chrétien, his brother Jean Chrétien I'm sorry, I'm biased, had developed several tools, the CFI and the Canada Research Chairs, and that gave Canada a boost. And even I remember reading about it 20 years ago, and Canada was put forward as an example how to promote research and basic research, university research. And that has been good, but now we have 20 years later, and it has not really been developed and fed with funds. The tools are there. They just have to be filled with money, and you would create more discovery. And I mean, we have seen it with the vaccines. Again, the vaccines are developed somewhere else. There's one company in Canada, I think, who was barely competitive to do that. But it was in other countries where this vaccine was developed. Although I think part of the discovery process, if I'm not mistaken, was done at the UBC. Hans-Joachim, you know better than me that. So Canada could do so much better. I mean, but Canada is a country which has enormous natural resources compared to Germany, which has none, or Switzerland. And the tradition is for countries with low natural resources to put all the money on innovation and technology. And Canada didn't need to do that because it's a rich country from natural resources. But I think we should not forget that if we neglect the innovation part, you cannot live only on natural resources, because this is, also a risky policy.
That's actually
I'd love to hop in quick
Sorry.
about the risk side of it too, because I think that Interweave's so good with that is if you have the funds to be risky, you can create a higher level of a product or innovation in the end. I think in Canada, we are so risk adverse in that sense, because we have to work within different parameters than maybe other countries who have more kind of financial pockets to work with. So essentially, like, if you can be more risky, you will have a better output in the end, in terms of like your ability to work on diverse things and try alternative methods. I think in Canada, we often have to like prove our worth before we get the funds more, because it's a bit more, they have to assess the risk before the funding comes. So that's the only thing I wanted to add.
Maybe if I may, for instance, if you talk to people in the biotech world, if you have an innovation and there's a venture capital person interested, more often than not always, but more often than not, they take it to a US firm and found the company in the US, even if it's technology from Canada, because there's more funds and there's more environment. It's not easy to get VC or venture capital to Montreal, but there is already some, and it may be one strategy to increase that. And the government certainly has done some into that direction, but certainly not comparable to the two hubs, Boston, one hub, and the other one, Silicon Valley hub.
So to bring this back to a certain aspect, because we were moving into the health sector and into the biotech sector, and I totally agree that being in that having a resource-based economy is part of the problem. However, or the chance or the opportunity, as you pointed out. But I think what we also, and that's probably because that's how we structured the panel, probably partially my fault, is we are coming from the natural sciences sector. But I think even in a research-rich or research-driven economy, it's important that the society, in order to be resilient to any kind of changes that impact the society, and global warming and climate change is only one of them, right? Technology change, disruptive technology, AI, or immigration, geopolitical change, those are all stresses to an ecosystem that we have. So like an innovation ecosystem, or like a society that needs to be responded to. And I think I would really like to bring this back to the added value of the graduate training or the research infrastructure that Canada has in all disciplines. There's so much potential for social innovation in Canada, or like how to deal with policies around these changes. And I think we should also ask for that, and to develop this and actually make this an important piece that we communicate and demonstrate that having those disciplines in that ecosystem as well. So I think it's important to talk about the value add of that ecosystem that is in crisis resilience, not just in economic resilience. With that, yes,
I can say something to that, because at least in North America, Canada, and the US, research and innovation is heavily immigration driven, right? I mean, we know this because, I have been a postdoc in the US. The lab where I was full of people from all kinds, Americans, yes, but, all kinds of people from all over the world. And I think they come with some degrees, do postdocs or even graduate training, and see all the opportunity and drive the whole research innovation complex forward. And I think this should be not, kept out of sight, that immigration drives health innovation, or innovation and research. Immigration has many other facets and many other aspects, but that's one. In North America, that's the case. And I think in Europe, it starts to be the case with the European Union and these big programs like Horizon. They attract a lot of people from outside and drive their innovation. This is now, the present situation. And this should not be forgotten. This is a part of immigration that's not really talked about.
Yeah, that also limits access to this. But it brings me back to the question, why is this the case? Is there more innovation and research potential in Canada than can be filled with our own youth? Or is this not an attractive career path for our youth? I mean, it goes in both ways, maybe, right?
I think the knowledge, a few years ago was that so US, Europe, Japan, if you want so, and now China, but then not, have put huge amount of money into research. And they look for people, to execute this. And for people that come from other countries that have less, infrastructure, they see this as an opportunity to go, they dream of science, they like science, they want to do it, they go there and they grow into the system, and they take the PhD, hard PhD, low salary and postdoc, and to make their lives and to fulfill their dreams. That's one of the promises of science in these areas. So there are other areas in the world that do not do that, and they provide the PhD students and the postdocs in North America, Europe, Japan, takes them, right? This is the dynamic that you see. But if Canada doesn't play along with this, Canada will lose out. That is the point I could make.
Maybe I could add, I think our world is getting more and more globalized. I think that's also partly what you're touching on. So there's a competition or kind of a comparison of what happens here and there. I think it's important that also international students come to Canada. And I think it's important that Canadian students go to the rest of the world. I think this exchange is also something that's very important to Canada, that the graduate students and the postdocs go abroad and see something from the rest of the world and come back again.
Yeah, and I think it's easy for us to look at brain drain maybe in a scary way, and even now, but it's a balance. I think is what I'm trying to say is, yes, we want our students to go, and I think in Europe, students inherently want to be globalized. They want to go to get diverse experience in other countries. In Canada, we're much more reserved, and it's not necessarily in our blood to want to kind of go abroad and have these experiences. But as you mentioned, there's so much benefit to it. And if we do have our graduate students going to do postdocs abroad, we just want to make sure that they're coming back and bringing their talents and their global connections back to Canada. So I think it's definitely it's a balance, but I think it goes back, Dr. Mora, you mentioned the Canada Research Chair investment in the early 2000s. This was in direct response to the brain drain crisis of the 90s. And so I think this is a perfect example of, well, we want them to come back. Let's create this really great program, what that incentivizes them to financially be able to come back and directly kind of plunge their talents into the pipeline again. So there's so much benefit to having international experiences. I went on an exchange during my studies as well, and I think I take a lot of those connections with me throughout my graduate degree, and I think it's super valuable.
In the Danish system, all our PhD students, it's mandatory. They have to go 6 months abroad or to another research environment to encourage this exchange. And it's impossible to get a job in Copenhagen, at least if you haven't been abroad for a period of years. But I think you might lose some Canadian students, but then you might get some international students back. And
exactly.
That's how I see the world, that we need to exchange. This also gives the best, knowledge networks and the knowledge exchange, which I think is beneficial for everyone.
Mm-hmm. Yeah, I'll just say our systems are not set up now to even allow most graduate students to be mobile in that capacity. So that's fantastic that it's integrated into the system. I think that's such a fantastic way to do it. In my personal experience, even just going on an exchange, it was extremely challenging to even make that happen. I had to put a lot of extra effort in on my end to facilitate that. So I think if that was inherently something that was more available to students, that would also be a huge benefit.
Yeah, so I think that's a great statement at the end to move from the discussion part to the question and answer part. I guess we had designed scheduled a couple of minutes to answer questions from the audience. And I don't know, do we have any questions from the audience? Can we see anything? Are there any questions? I don't see it. Well, we can keep on going. It's not a problem. We have questions and topics to talk about. So with that being said, to the audience, if you want to have a specific question to one of the members, for instance, on this panel, please feel free to enter them in the Q&A or into the chat, and we're gonna read them out. While we're waiting for this, I would like to give. We had a question, or I think I have a question regarding. It goes around. So I actually want to make a statement regarding the graduate students and the transfers, and that's the incompatibility of the funding streams between the Canadian and the European systems, for instance, because it's very hard for a German, for instance. I just noticed from a personal example from a student in my lab to actually move into the Canadian funding system, because 90% of the scholarships are not accessible to that individual, right? And so which makes it a semi-attractive proposition. So that makes this exchange difficult, although that might be important to do this. But I think another question that arises from the innovation space is indeed, and we touched on that about through the courses, how do we deploy and how do we make sure that the communities and the policymakers understand what we're doing. But we're also changing value propositions here, and Tarek touched on that a little bit when he was saying, yeah, we're healing more diseases and we have super sophisticated technologies that are rooted in super long investments into research, but it also drives the cost of healthcare up, right? And how do we do with this? This becomes a economics challenge, but it comes also B, an ethical challenge, right? And so Tarek, do you want to talk about this a little bit and reflect on that?
I think I can reflect on it. I'm not a health economist. I think that what we see in Quebec, because I'm here, and what we see in Germany, for instance, is efforts of the governments and efforts of the payers, of the insurance companies, to balance that. So there are different approaches. The Canadian approach is the state-funded insurance system. And I think what happens is the provincial health assessments, right? If you have a drug that's approved even by Health Canada, the provincial authorities for health assessment have to decide whether it's been paid for or not. So there is the key. And this body of health assessment is, of course, influenced by many things. Do you pay for something that has been developed in another province? Is that kind of or do you pay for something that's developed in your province? So I think there should be attention given. The health assessment is a critical thing, because you can develop a drug and the drug is FDA approved and Health Canada approved, but it's not paid for, so it's not used. That's an issue, and I don't know how to plan it, but it's a big problem that has to be talked about. Now, do you want to have a two-tier system like Germany has, where you have public health insurance and private health insurance, which is clearly two-tier and which solves some of the problems, because all of the insurers of the health economy system in Germany get around one table and dictate to the pharma industry what they pay for their drug. They have this power because the pharma industry will not leave Germany, but if you do this in Canada, the pharma industry will go to the US and say, 40 million people is not enough, we go to the bigger market. So there are the problems, right? And I cannot, I could just, elaborate on the effort that Canada and the provinces make to make this right, and the effort that a country like Germany does to make this right. And both are not perfect, and both lead to higher costs, and both lead to, we have to deal with this as it develops. So you have to repair the aircraft while it's flying. Unfortunately, that's what it is.
So thank you, Tarek. We do have a question from the question and answers. And while we're doing this, I want to ask the attendees quickly to answer a moment to answer the webinar poll that Trudy is putting on. I of course forgot that in the beginning, but I remembered, so now there's the poll. And so please go ahead and fill out the poll. The question that we have is, how do the levels of stipends for graduate students in Canada compare to other G7 countries?
I take that one. So Canadian PhD students make on average about $21,000 a year. a postdoc about 45,000, and that's the values of the federal scholarships for that, or just below. In the United States, these are often 2 to 3 times larger, which is, I think, the biggest competitor that we have for that talent. NSF grants are $65,000 Canadian for a PhD student, and can range to upwards of 85 to 90,000 for a postdoc. So again, double. If we're looking to Europe, I'm sure Dr. Dahl, you've heard of higher salaries than what I'm saying as well. Specifically, a lot of the Scandinavian countries have amazing salaries for their trainees and postdocs. So I'll also make a note of Australia as a unique example as well, that actually indexes their salaries to the Consumer Price Index every year. So this is a sustainability type program where it's inherently able to adapt with the times. So I think this is definitely indicative of why students are going abroad to pursue these types of degrees. But yeah, definitely troublesome.
Yeah, I agree on that. It's not easy to convince a postdoc being in the European system to take a postdoc in Canada. You really have to tempt them with really, really interesting research before you can get people to move.
Mm-hmm.
But it can be done, but it's just not so easy.
Yeah, and again, like we mentioned, a lot of the awards specifically from the federal government aren't open to international students or talent. So that's also a big detriment to this, is that they're often then relying on that indirect funding through supervisors, which would be inherently a little bit lower than the value of any of these awards. So yeah, that's another policy aspect of this.
Yeah, it is quite difficult but we see it's not just Canada there. There's a lot of countries that have very different rules for their salary, and of course it moves the students back and forth how the conditions are. PhDs are gets high salary in Denmark, so it's very attractive to be a PhD student. Postdocs might get higher salaries in other countries, so they move out again. So is that a smart move for Denmark? And every country has their quirks on how you can do it best. Yeah. It's hard to say what is true, but I do think the salaries are a little low, to really be attractive in Canada.
Dr. Morroy?
Yes, I think maybe we could look, if you look at Germany, you have PhD students that have salaries, right, not stipends. And certainly the postdocs get salaries. I mean, there are employees, not fellows. And I think you see the same in Canada coming and developing in Ontario. I think the Ontario labor law requests that postdocs are paid salaries, if I'm not mistaken. So that brings the money that a researcher has to take from his or her grant, it almost doubles it. So yes, we can do that. I have research associates in my lab that are postdoctoral research associates that I pay salaries for. But if I pay a $45,000 stipend, is a different thing than you pay $80,000 salary with all the deductions. And if the grant is big enough, I can do this. But that brings these grants from the CHR to the limit. So the solution, Sarah, forgive me, would be not necessarily only increase the fellowship program, right, of the Tri-Council, but increase the grants. But the grants are cut. The CHR grants are cut for 23% across the board. So, if they weren't cut, of course, the success rate would be very low. But if they weren't cut and the success rates were 20%, you could pay a postdoctoral salary instead of a stipend. That would also resolve one question. The postdocs are not students, shouldn't be considered as students, which they are for now, but employees. And that give them, a salary with deductions and a more reasonable situation. That would be the solution. But that would mean put a lot more money into the granting system.
Sorry, go ahead.
Yeah, I would like to bring this back from asking for more money into the funding system, because that's actually a difficult question, because the Canadian government has provided additional funds to the funding system, but not necessarily in the streams that you are referring to, Tariq. And I think that is not necessarily always the right answer to this, because I see, I understand that there needs to be money for these kind of things, but I think there's also roles to be played within, I mean, the system is completely different here, right? So we have to be careful with that when you're comparing with the German system, right? So there's also roles that, for instance, the community plays within that, you know, within the innovation system and in the research endeavor, right? Because separating it, just making this a responsibility of the government, takes it, I think, away from the impact that it has for the whole society. And as such, it might be actually beneficial to engage more partners in that entrepreneurial or in the research endeavor than just asking for funds from the government, right? And so so things that one could like, you know, groups that one can ask for is like, what is the engagement? I mean, we're not talking about philanthropy, which has a clear role in this as well. And some of the research, particularly in the health research sector, they are philanthropy driven, right? But you know, what is the role that a community or community scientists play in this, like in the impact that society has for the community in itself, in the dissemination of knowledge and tools to do science and understand what's going on? And do you have opinions about the role that, you know, anybody wants to take it? What's the role of citizen scientists in our ecosystem? I guess that's the question.
Well, I can bring something up that's very much on my mind, because Canada is such a really, really big or large country. And, you know, the North, you have a very sparse population living up in the North, but very, very remote. And when you talk about communication and education, you run into a totally different set of questions when you move up north. You know, just a matter of being a student and being able to go to the universities in the South and can you come home and visit your family and things like that is a totally different aspect of you know the system, and also dissemination and movement of knowledge in Canada. That your country is in that way also very diverse, from highly populated areas in the south to very sparse and remote areas in the north.
I'll just add to the transparency aspect of it is so huge as well. Getting citizen scientists more involved in these types of things from the ground does allow for a level of transparency into the process that maybe isn't typically seen. So engaging with those communities and having that dialogue opens up that door for more public trust and more trust in the process in its entirety. So yeah, I think you said this in the beginning, Dr. Dalba, just being really authentic, right? And I think that's what it comes down to is having authenticity and compassion in citizen science and meeting the groups kind of where they are and allowing them to be involved in ways that they want to be involved in the process. But I think it ultimately leads to improvements in like the public perception of science as a whole. So yeah.
I like to mention something that I've noticed last summer, because moving up in the north and traveling with airplanes, suddenly on the baggage you see there's a lot of starlings, cardboards with starlings moving around, and for me that seems to be a very big game changer. That when we get the starlings is easy and not super expensive, that it will allow the communities to join societies in a way they've never been able to do before. And that goes for knowledge and education, but also for health and medical care. So I'm very excited about how we can use these opportunities to kind of bring our societies more together between the South and the North. Have you experienced anything, Tarek, you know, related to communication with the North?
I think the only knowledge I have is indirect from colleagues, medical doctors that go to the North and practice, or colleagues that do genetics and try to do to win over indigenous communities to participate in genetic studies. But that's all indirect knowledge that I have. So I'm the typical example that you portray. I live in the south, in Montreal, which is a densely populated metropolitan area, and I have not very, no relations into the far north that you have because you work there. Right? But I think the relationship with from what I hear from my colleagues is not an easy one. If you the medical doctors that practice in the north, or the geneticists that go and try to communicate with indigenous people to say, well, we would do a study on diseases. Would you be able to give blood? That's very, you have to be very careful to explain this. And then often what I've heard, indigenous communities are not ready to participate in these kind of studies. So I think there is a lot of things to do to bring these populations that you describe from the north and from the south together.
Tarek, that's an excellent example for how the technology development, like the ability to actually launch Starlink, right, which is a technology achievement, right? The small satellites and whatnot. So that is an impact of science that we feel in the society that you're just describing, because it suddenly makes in remote locations data available, and you can start planning around this, right? But it also provides the opportunity, but it also allows for misinformation to be distributed, and so on, which then also creates the need to co-develop the education and the use and the skill sets or the tools that people have to actually engage with that, and not being exploited for whatever the more technology advanced communicator has in mind, right? So I think that is an important piece where I think science and society are in a very, very important intersection. They need to co-evolve, and we need to have a healthy infrastructure or like an ecosystem to do these kind of things, right? But back to the impact, that's a felt impact in the society. They will understand, like, this, if you suddenly have access to internet for a low cost, they understand the impact that innovation and the science behind that had for their personal lives, right? And I think these impacts need to be, we need to celebrate those, because they actually show why we're doing that. And I guess, yeah, that ties that a little bit up, I guess. Sorry for but it's a great example, and it's a not health example for that technology base, for instance, right? But and what it also will create is there's a value add component to this that increases the resilience of the Canadian economy to this, because all those devices need to be serviced, right? There's a whole other business sector around that actually that is engaged, or that follows basically the scientific impact and the access to the north. I think, sorry, my statement for that, but I think it's a great example for the incubation. I have one. We're getting towards the end, but I really would like to tie this a little bit up with another question that I have, and that goes. I think it will bring all three of us together, all four of us, I should say. Is so with having from my province, we have Churchill that is located at the Hudson's Bay, right? And we do have train connections that are central to North America and basically can directly connect the Churchill with the rest of North America through a train and a trucking network, right? What would be the societal impacts of innovation and research that we get about, for instance, how to access the port through through the Hudson's Bay, and probably having more shipment routes going through the north, and what are the next things to do in this context? Is there, like, what are the challenges? What are the challenges for the communities there? What are the challenges or the results from global warming? What is important for the graduate training or the training in general for the communities, and what are health impacts on that? I think that might tie this a little bit together, and from a Manitoba point of view.
Yeah. Well, there's no doubt that exploring the train as a way of transporting goods up to Churchill and having ships to bring it out will kind of bring Churchill more into the communities to the south and develop Churchill a lot. To some degree, it's still exporting low level processed goods from Canada, as we talked about before, there would also be a value in trying to kind of refine some of the goods, not just export them. And this could also be something that was related to Churchill, that you would build up kind of ways of kind of small industries up there that could refine the goods, and I think that could strongly bring some developments to Churchill. But I'd just like to mention the last thing there is that many of the communities living in the routes that the ships will take are not very happy about all the ships that will be going through the straits, because it disturbs their natural life and fisheries and conditions, and there's a big move to control that a little more. So there's things going both ways with expanding the shipment up to Churchill, in my opinion.
I'm struggling to see a graduate student answer to this, but I think I might just revert to kind of like how graduate students can be involved in these types of situations. And I think that it might just be more about, oh, can you hear me?
No, I can hear you. Can you hear me?
Yeah. I can hear you.
I can hear you.
Okay, sorry. I think to go to that point, I might just say like it's about how we as scientists also kind of talk about science to these communities and how we frame it. And it goes back to kind of the communications things that we were talking about at the beginning, which I think is a really important aspect of this. And like the perception and life experience and value sets that we have are different than all of the communities across Canada, depending on where they're at. And none are more important than each other. Like I think they each have very important views. And I think coming into each strategy of communications from that angle and kind of meeting the communities where they're at is an important strategy. And I'd written a note earlier about like how do we communicate uncertainty, because I think that's a big aspect of this. Is we often tend to speak in absolutes when it comes to science, and I think that it's a bit harmful. So I think it's important to kind of emphasize that science is ever changing and it does change and it's uncertain sometimes, and I think that might help in some of the communication strategies there.
Yeah, I think I could not say it better. I think it comes also back again to the beginning of our panel, to the trust, right? So how do you build trust? Why do you lose trust in societies? How can you remedy that? What's the worth of authority? Is there loss of authority? And is this good thing or not? So if we lose more trust in the North, or we gain more trust, that will change significantly how science and innovation will penetrate the entire society, even in the North. So that I think is, and I think the trust for science and innovation in the northern populations, from the little information that I have in the experience, is almost nil. But from what I read and hear, trust is even lower in the northern hemisphere towards what the industrialized South has in science and innovation. But maybe that can be changed by better communication. And I think maybe satellite communication, internet, social media can help to bring people together and build trust. And these innovations can penetrate the whole Canada, not only the big cities and the South that bordering the United States. So it comes back to trust and communication.
I think that's true, but I think it also in many cases comes back to give and take. For example, in the North, I think cruise ships in general are extremely unpopular because you have these big ships that come with these people. They go into the communities, they gawk on the people, they don't give much to the communities, and then they just sail away again. You have to be careful whatever you do, also with a railway and exploring Churchill, that there also has to be a give component, that it's not just that it's a great harbor for Canada, that it has to be something that Churchill benefits from, and they can see the opportunities in this development.
I think I agree completely, and that's not so difficult to understand. If you see a big cruise ship of several thousand people coming into a smaller harbor, you see this in Europe, by the way, even it is somehow strange, and probably the frequency by this happens is not sustainable.
Yeah, so I would, I mean, we're almost on the hour, so I would like to tie this up and maybe ask the audience to fill out the feedback poll that we have to see if we can maybe improve these activities. But to tie this up, I think what we heard here is, and we tried to explore, is the complexity of and diversity of the impacts that the science and innovation ecosystem has for societies in general, and that one actually, and that's what was nicely demonstrated in the panel discussion. That it depends on the communities, what the values for their communities are. I mean, we reflected, for instance, I mean, we had a longer discussion with communities in the north, because I think that is an important aspect of that, and that's related to Dr. Dahl's work. But we also talk about graduate students and trainees as a community that has a vital role for the ecosystem. That's often not necessarily seen as a community in that regard that needs to be considered. So and Dr. Mora pointed out the trust relationship issue that is critical for moving forward, in particular in an ever-changing or faster-changing society that has more and more disruptive impacts from science, but as well from societal impacts. And the trust relationship, and we kind of talked about this, is built on a fair engagement where where the benefits have to be demonstrated. And I think it's important to understand that the communities with which you are building these trust relationships are not just local communities. There are also institutions. So among institutions, between decision makers, they are all a community that needs to have a trust relationship among each other to actually move change forward. And this is a complex endeavor, and I think it requires training on both sides. And I think that science can play a critical role in providing the feedback, or providing the tools to having an informed discourse about risks, about opportunities, and an unbiased assessment of what can be done, what should not be done. And we touched on a couple of things. If that is a fair summary, and if anybody of you wants to do the final 3 words, then I would be happy to give that to you. Sarah, do you want to say something to that?
I think you said it very, very nicely. I think there's an opportunity here to engage with diverse stakeholders. I think that's kind of what we've been chatting about today, is engage with outside of our silos of science and research, and engage with policymakers, and incorporate graduate students and youth into these discussions as well is super important. So I can just end it on that. I think that's a good kind of testament and a good wrap up of the session.
Yeah. Any last words from everyone? I think science and innovation should be a priority for the government. I understand that the government has many priorities, and science and innovation should now not fall by the wayside.
Although the words you said are so perfect, it's difficult to match them. I think it's really, really important that what can you say, the food chain is there, that it's attractive to be a graduate student and a postdoc in our educational systems. I don't think a country in our generation can thrive if we don't have a healthy food chain and a good stock of students and that engage in innovation and fundamental research. This is going to be more and more important in our future, and something I think should be kept there for all costs.
Okay, so with that, we are almost on the minute. I would like to thank the panelists for a very engaging discussion, and hope to see you in person soon. Thank you very much
for having us.
Thanks.
Thank you very much.